Ah, calculus, the nightmare of many students, but pretty much interesting for others. There are a lot of themes and functions in the wide area of the mathematics world, but right now, at this specific moment in life, we're going to talk about one of the most interesting and funniest themes of mine, I think, of algebraic functions. Have you ever been frustrated with your neighbors or your neighbors' children? Don't you hate when they step in your garden with those filthy hands and feet and dirty clothes over your beautiful grass? Well, this is basically what we're going to talk about in a creative way. Piecewise functions. Let us make functions that do anything we want. Basically, that's just how they're named. A function can be separated in pieces, so we put the pieces of different functions all in one graph. The easiest way to think of them is if you drew more than one function on a graph and you just erase parts of the functions that where they aren't supposed to be. They are defined differently from different intervals of x, so y is defined differently from different values of x. We use the x to look up what interval it's in, so we can find out what the y is supposed to be. I love math theory, right? But don't worry, we can show you what piecewise functions are in two different examples, one made with a lot of imagination and creativity basically for children to understand, and the other one based on much more in situations happen in real life. In this first example, we get a simple way to keep all the pieces straight, so if you loaded them before, no fear. Imagine we just have this equation, y equals x plus 2 if x is less than 1, and x minus 1 at square if x is greater or equals 1. It's in two pieces, so each piece must live only in its own neighborhood. So let's put up a fence, so we don't have any problems with the other neighbors. Next, we just need to figure who the fence owner is. This guy has the equal sign, so he gets to live on the fence. Let's graph part or neighborhood number 1. He doesn't get to sit on the fence, and he can't be in this neighborhood. Now let's graph the neighborhood 2. Close dot since he owns the fence, but he can't jump to the other fence. And we're done. Obviously this is a basic rule, so there is still a lot of doubts about the signs and their relation with the x and y abscisses. Don't worry, we put them all together in here. We can create functions that behave differently based on the input value. A function can be made up to 2 or 3 different pieces. Here's an example. So what this means is for every x less than or equals to minus 2, we need to graph the line 2x plus 8 as if it were the only function on the graph. For every x value greater than minus 2, we need to graph bold x, as if it were the only function on the graph. Then we have to get rid of the parts we don't need. See how the vertical line x equals minus 2 acts as a boundary line between the two graphs? Note that the point has a closed circle on it. Technically, it should only belong to the 2x plus 8 function, since that function has the less or than or equal sign. But since the point is also on the bold x square graph, we can just use a closed circle as if it appeared on both functions. See? Not so bad, right? Now let's pass right over into the second example, based on cases of the real life. So, a doctor's fee is based on the length of time. Up to 6 minutes costs $50. Over 6 to 15 minutes costs $80. Over 15 minutes costs $80 plus $5 per minute, about 15 minutes. So, we can write it like this. If t is less or equals than 6, 50. If t is greater than 6 and t is less or equals 15, 80. And if t is greater than 15, we use that formula. So, let's pass to the questions. If you were there for 12 minutes, what would the fee be? And if you were there for 20 minutes, what would the fee be? If you calculate it, you'll see that for 12 minutes, the fee will be 80. And for 20 minutes, the fee will be $105. I hope you really enjoyed this presentation and the thing we talk about, so hopefully you get the inspiration to make a similar video, just like this one. My name is Alan Miguel Fernandez and thank you very much for watching.
Created using Powtoon.